Hi, everyone, and welcome back to another SAE Government Technologies LinkedIn Live event. My name is Mark Pickett, and I'm the Technology Transfer Program Manager here at SAE Government Technologies. For those of you in the audience that don't know, SAE Government Technologies collaborates with government, industry, and academia to solve the world's toughest mobility technical challenges. I'm here today with Lauren Tubising and Mark Shaw with the National Institute for Aviation Research. Today, we're talking about the technology battlefield in the context of advanced manufacturing, and specifically additive manufacturing. We'll be discussing why this is a national priority and a convergence technology, which we'll get to in a little while. Further, we'll be discussing how performance-based additive manufacturing part qualification will transform the defense industrial base, military readiness, and contested logistics and commercial industries. As a note to our audience, if you have questions, please use the comment section and we'll make sure to address those questions at the end of the event today. I've had the pleasure of working with both Lauren and Mark in the past, and they bring tremendous industry experience. So let's jump in. Welcome, Lauren. Welcome, Mark. Please tell us about your role, your background, and what you do at NIAR.
Well, hey, Mark. Thank you so much for having us on. This is a great topic, and we're really excited to be here today. So we appreciate you organizing all of this and welcoming us here. Like Mark said, my name is Lauren Tubising, and I work for the National Institute of Aviation Research. We are the research arm that is associated with Wichita State University. So we are based out of Wichita, Kansas. And what I specifically do is I am the director of operations, and I run the programs, and I'm a business development leader specific for additive manufacturing. And even though I've only been at NIAR for a little over a year, coming on a year and a half, I fell in love with additive manufacturing when I worked in industry. Worked in industry for 10 years, all focusing really on our government customer and heavily focusing on sustainment. And about past 3 years of my life in industry, I really started to see how you can take additive manufacturing and apply that to sustainment problems that our warfighters are fighting. And it just felt, we can get into convergence technologies later, but it really was just this eye-opening moment where I really knew that this technology could truly change the world and do amazing things for our warfighter. Before industry, I was also in the Air Force. I was a finance officer. I was just joking earlier with Mark and Mark that we were cashing checks and breaking necks very long time ago, pre-Space Force. So I feel like I date myself these days. But that's really where my love for this technology and for the application that Mark and I specifically work on, that's where this love and this passion came from. So work at NIAR, but have history working active duty Air Force and also within industry. So thanks, Mark. Excited to be here.
Thank you, Lauren. Go ahead, Mark.
Hey. Yeah, thanks, Mark. So I spent most of my career in industry, 35 years plus I've been in industry, most of which was in aviation. I'm really just an old jet motor part designer when it comes down to it. I spent the last 12 years working in industry in additive, so had the opportunity to lead teams that certified the first metal AM part for FAA, similar thing for the Air Force most recently. What I saw in industry, what they were able to do within, I'll call it the closed ecosystem of a proprietary system, I was not seeing out in a public or commercial. And in other words, additive was not growing in the way we thought it was in the year 2012. So my motivation, I retired and then got a full-time job. I now work at NIAR, and really my motivation and mission is very much the same as Lauren's. I'm very much motivated for scaling the industrial base. I often say 10x in 3 years or 10x by 27 as just a self-motivating factor, but that's really the thought is what I saw happen in that period of time within private industry. Lauren and I and others are working together to do within the larger ecosystem.
Thank you, Mark. Really appreciate that. And before we get into part qualification, to assist the audience in understanding the context, from each of you maybe, what is meant by convergence technology?
Yeah, so maybe I'll jump in first, then Lauren can add some color. So convergent, in my mind, it is what the words say, two technologies that converge together, kind of like fusion food, I suppose. And in the context of additive, I often refer to additive as castings. So if you think about castings, which have been around since the Bronze Age, maybe for aviation, we'll say only in the last 100 years. But this idea of making metal form by pouring hot metal in a mold. And we did that in the aviation space with obviously all the appropriate controls. That's happened really until about 10 or 15 years ago when metal additive became a viable technology. At that time, we all knew computers, we all knew digitization, we all had a phone in our hand. So the convergence here is the convergence between the analog, pouring hot metal in a mold, and the digital, which is taking something and turning it into voxels or tiny bits, and then reproducing. And so additive does that. Additive takes a part that's rendered in a CAD system, in a computer system, 3D model. It is then sliced into tiny layer upon layer. And then with most additive technologies, it's almost point by point reconstructed. So a laser or an arc weld or some other means will basically reproduce the metal layer by layer. And thus essentially create what we were doing with analog castings traditionally, we're now doing with a digital technology.
Great. Thanks, Mark.
So,
yeah.
Sorry, Mark. I'll use Mark Pickett, Mark Shaw. So it's not too surprising that when I was hearing about convergence technology, I had a little bit of a different take on it than Mark Shaw did. I first heard this term probably about 6 months ago, so pretty well into my additive journey. And the examples that I always read about was an iPhone. The iPhone converged these capabilities like GPS and a camera to a handheld device. It was converging two different things into one. But I actually, about 6 months ago, maybe not even that long ago, probably about a month or so ago, found the Henry Jenkins model of convergence. And it's interesting because it's actually on social media. I actually saw it when flipping through social media. And he's like a media relations marketing guru. And he said that there's 5 areas of convergence. And he talks about technology, economics, social, organic, cultural, and global. And I haven't read the whole book, so it was just the Cliff Notes version. But what I really, really found interesting about his model of convergence was, at least when he was talking about the application of that to social media and what it's done to that industry, that it's taken over the distribution and control of content. It's changed the power of distribution of content. And that's really a parallel that I see with additive manufacturing. Additive can really change the power of who can manufacture what and where you can manufacture what. So we'll get probably very heavily and very deeply into the technology and how do you make this work and how does it all happen. But the business model around additive manufacturing and how do you disseminate that? How do you market that? What are the business models? Who's making money? And all of those kind of extras, those also have to come along with it. So I found that very interesting that there was a parallel in my mind between the convergence of technology that they're seeing in the marketing realm right now and additive. And that I think additive is really changing the distribution and the power of control of components that used to be castings and forgings. Absolutely, Mark Shaw. But there's been a shift in power, and it's really converting this capability of who is a part owner in the logistics of spare parts specifically with this awesome new technology and digitization. So I find it fascinating, and I'm sure you could take it down a million different rabbit holes, but that's where my brain goes when I read convergence technology.
Thank you, Lauren. It's a great perspective. Go ahead, Mark.
That just tells me your social media is listening to you. If it's giving you articles on
100%. I mean, I block all the things and it still knows. So yeah, you're right.
I think that's what I like about working with you both is there's obviously a mutual respect, but you each bring perspective that's a little bit different. So diversity of thought is always a good thing.
Okay.
Yeah, Mark, I want to ask you a specific question because I really think that you've lived this for so long, but help the audience understand what you mean by performance-based part qualification.
Yeah, it seems like a minor point, but as all things are, it really ends up forming it helps us form the way we think about the world. at least in regard to additive technology, that world. So I'm going to take us into the kitchen. This is maybe it'll be relevant for those of you listening. So I'm going to contrast two things. I'm going to contrast the prescriptive method of qualification and the performance method. So if you are a prescriptive method cook, what you do is you either buy cookbooks or you look on the internet and you print out that recipe and you measure if it says a half of a teaspoon, you are sure you level it off with a knife and you dump it in and you follow that to a T. And you know that sometimes when you do that, it still doesn't taste right. Like it's still not, something's off. And you're like, well, how can that be? Like I was very, very careful. The performance-based cook, and I'm probably more on this side of the spectrum, is I read multiple recipes, I get ideas of where we want to do, but I have an expectation of what I want it to taste like. So if you've ever watched cooking shows, they always tell the cook, you must taste it. Like if it's bland, add more salt. Maybe put some pepper in it. If it's too spicy, then do the opposite. You need to add something else, add some milk or something and that's not in the recipe. That's you're tasting it. You know, obviously if you're tasting, I don't know how you cook noodles. I don't use a timer. I test the noodle. If it's crunchy, I boil it longer. That is performance-based qualification. There's a standard by which I want it to be. So let's bring that back into the factory. You can kind of see where this is going. So a prescriptive-based qualification approach is very much, this is what you do. You take A and B and add it to C and then do B and then hold it for D. And then when you're done, out is the product of that process. And just like with cooking, sometimes you get unexpected results. Even if I've controlled everything I possibly control, it might be humidity. It might be the particular powder I bought or the wire was different. You know, it could be 100 different variables, just like with cooking, that aren't controlled by the recipe. Performance-based cooking is the opposite. I'm going to, if I care about things like tensile strength, well, I'm going to measure the tensile strength. If I care about like how much porosity is in the printed part, then I got to check and see. And if any of those don't meet my expectation, it doesn't taste good, then I'm going to change the process. Now, don't confuse to say, we'll still lock the process when we're done. Once I figured out I'll call it my own personal recipe, I will fix that process. I will continue tasting it over time to make sure it doesn't drift out of process. But I will develop the process that works with my machines, with my people, in my factory, in my state, with my humidity, with my temperature, like my, and then I get. So that's really when we talk about performance-based qualification. We're really talking about establishing what's important and then ensuring we meet those requirements at the end of the manufacturing process.
Thank you, Mark. I'll start with you, Lauren. Why is part qualification such a national priority?
Well, the reason it's a national priority is a topic in and of itself. When I was in industry and even from my Air Force days, I still have a lot of friends who are flying. Sustainment is a big one, and that's not the only national priority, right? But being able to manufacture within the United States is important. And it's a national priority to make sure that we can answer our own demand signals and we're not relying on foreign entities or foreign parties or foreign countries who might not be able to A, get it to us quickly, or B, might not want to get it to us at all, right? So it is being able to do that and to do that quickly is what's really important. Now, the performance-based approach, and we're going to get to a little bit later, but that's going to allow us to capitalize on the installed base that we already have in the industry. If you're going with this very prescriptive-based approach, either everybody's going to have their own way of doing it, so that's going to really limit how you can widely disseminate this capability and this requirement to lots of different suppliers, or you're not even able to capitalize on it at all, and the cost is going to be very high. So if you have different standards, different people always doing it, the cost is going to be incredibly high, and it's not going to be a manufacturing capability that we can leverage. So being able to have a performance-based approach and being able to decrease the cost because of the democratization of this technology across different supply bases and suppliers is going to decrease the cost. Let us leverage it and use this technology more so we can increase the manufacturing within the United States, so we can kind of control our own destiny, if you will. Anything I missed, Mark Shaw?
Like previously, our
Yeah,
brains
lots.
work very, very
You can go
differently.
anywhere with it.
So your comment, Mark,
Yeah.
was right on. Yeah, we will give you both sides of the coin here today. Yeah, so when I think about two things with regard to national priority. One of which I'm old enough to experience when we began exporting a lot of our manufacturing and trade outside the U.S. We sent it to, it was all for good economic reasons. It helped companies be successful. However, the result of that is that now many of those technologies, we no longer have the capability or the economics to support. And for a large part, they're in countries that may not be our friends or not our closest allies, perhaps. So that creates a national risk. And then world events, I don't need to tell you about world events. There's an increased concern about where we're going to go. My 10x in 3 years is specific to we might only have 3 years before we need to really start scaling our industrial base. 10 is a random number, but it might have to be by a lot. So 10 seems like a good first step. And so the likelihood of us recreating, I'll say, these 1950s technology, i.e. pouring hot metal in molds, hitting with 1,000-ton presses to forge metal. We'll continue to do that, but we're not really set up as a nation to scale in that way. How do we scale? By modernization, by technology. That's how we're going to scale. That's how we've been successful year over year, becoming that arsenal of democracy, as it was called in World War II. So additive, back to your convergence question, additive is that convergence. How do I make castings and forgings? What happens if I need 10 times more tomorrow than I did today? I'm unlikely that it's going to happen in a traditional foundry. That will happen to some degree, but are there other ways that we can get to the same solution through technology? And so to me, that's why we're hearing through Office Secretary of Defense and others a priority on modernizing our industrial base.
Well put. Appreciate that. Mark, let's go back into the kitchen. What do you believe SAE's role is in creating performance-based qualifications?
Yeah. So we definitely need the recipe. My prescriptive performance, in both cases, we use a recipe. In one case, we're testing to see if it tastes good or not. And then we're kind of locking in the revision. So we definitely need those basic performance standards. So that's I'll say the first row in my building block. There's a qualification framework that some may be familiar with. It became popular, I'll say, I think it was about 2020, so maybe about 5 years ago. This idea of IQ, OQ, PQ. Installation qualification, operational qualification, performance-based qualification. Those are really just steps that say when I installation qualify, I'm basically showing that my machine works. I've accepted it on my site. I've done some basic checks and say it works the same way it did in the factory in which it was made. OQ is now the marriage with that material spec. It's going to be an SAE spec, an AMS spec. AMS 7000 is power laser bed fusion for Inconel 625, for instance. But it's going to say now I have a material. I have a material like Inconel 625, and I have a machine by which I bought. The marriage of those two meets a qualification standard. That qualification standard is a performance-based qualification. It will have tensile strength. It will have chemistry. It will have microstructure. It will have all those things we care about. And then just to finish out, the PQ is now I introduce a part. OQ is kind of, the foundry's open, I have material, I'm confident in its performance. When I introduce the part, things can change. I have thin walls, I have super tall parts, I have multiple lasers, I have critical parts or less critical parts. All those things are consideration on a part basis. And so we need guidance and standards around each one of those. So I'll give you a quick anecdote. So one of the things I'm doing this year is I'm traveling around the US and I'm visiting as many metal additive suppliers as I possibly can. I'm at about 20, most of them laser powder bed fusion, but some DED and some others along the way. One of the very strong messages I'm hearing over and over again, as we stand in the middle of these manufacturing floors with the machines humming all around us, it's sort of the frustrated, vice president, president, owner, operations manager, whoever's giving the tour, and says, see this See this machine over here? This one is qualified to a Navy standard. This one's qualified to an Air Force standard. This one's qualified to a NASA standard, right? So it's not just that we need a standard. We really need leadership that says this is going to be the way that we have confidence, so that NASA, Navy, and FAA, everyone else can have confidence in the performance. And we're helping the suppliers so they don't have to do it 5 times. They have one qualification, the AMS 7032, for instance, and then everyone is confident in that result.
Thank you, Mark. Just a reminder to the audience, if you do have a question, I see questions start to come in now. Feel free to type your question in the comment section. I appreciate that very much. You mentioned visiting suppliers. Obviously, you're interacting with government agencies. Can you help us understand, the relevant government and commercial stakeholders when you think about part qualification?
Yeah. So stakeholders. So there's a long list of stakeholders. That was the SI. I've been talking to a lot of people in the 6 months. So let me just kind of summarize them by topic, and then maybe we can dive in on a few. So regulators. If we're talking about something that's flying or sub-safe or medical, there's a regulator involved. And whatever this qualification standard is, no matter how much I'm convinced of it or the standards committee is convinced of it, if the regulator doesn't recognize it as being safe to move forward, we're not going to go anywhere with that standard. So regulators, I always start there, number one. The second is the standards organizations. As Mark knows, I've gotten to know them very well over the last year or so, because we've been spending a lot of time with SAE talking about, okay, once we establish this and we get agreement across the industry, like we need this in a public place. Like having it on Mark Shaw's hard drive is not going to be helpful to anyone else. So we need to really provide this in a way that's a public standard. So the standards organizations, and honestly, I've been talking to ASTM, AWS, even DoD, who has some unique, right? So who are those people that are going to manage and control that standard? Suppliers, as I said, I'm visiting 20 different suppliers. We don't want to create a standard that the regulator is happy with, because I'm doing 200 coupons and they're all tensile and fatigue and fracture, but no one can afford it, or you can't actually execute it. So, a stakeholder we often forget are the people at the pointy end of the spear who's got to go make stuff. So they've been a real big part of this conversation as well. I don't know what I forget, Lauren.
So I think you was what I would think is probably one of the most important stakeholders, and that's the person integrating all of those different stakeholders together. Like Mark Shaw mentioned earlier, he's been visiting all of these suppliers. They're pointing at 5, 6 different machines, talking about how they're having to qualify to different standards for each of those machines. That is extremely expensive. Back to, how do we democratize this? How do we turn this installed base that we have within the United States from a capability to an actual capacity that we can leverage? And the way that we do that is by connecting all of these stakeholders and getting to a consensus. And I'm not going to say that everyone's going to agree, but bringing everybody together from their different silos and bring them all, at least so their silos are close enough together that we're working together. And that's not an easy feat. And that's something that there is a team of people. Mark and I are not the only ones. There's a team across industry, suppliers, government, really working to do this. But that's what's needed to happen. It's the alignment of the regulators, the standards committees, industry, DoD, customers, acquisitions, getting all of those people to come together and to align so that we can actually turn all of this capability. There is a lot of capability out there. There are a lot of additive machines that people have. But how do you turn that to a capacity for the DoD? How do you turn that to an actual capability that we can leverage within the station? And I think that the stakeholder analysis, Mark got it spot on. I would just say the one thing that we need is that integrator to get all those stakeholders together, aligned, so we're all marching in the same vector.
Good point. And I think about, once performance-based qualification is established, what does that end zone look like? What outcomes are we expecting to achieve at that point? I'd love to hear your response to that question.
I'm happy to go. I mean, we're probably talking future, like the dream. I think the pie in the sky dream, if you're thinking of like application for our warfighter, is they're downrange, they need a part, and they call somebody and they print the part and they have the part. Are we going to get there for, maybe propulsion components and be able to do that within 5 hours? Within 2 years? I don't know, but that's the dream, and that's what we're all marking towards. But I think really at a high level, I think additive, the dream would be purchasing a part would just be purchasing a part. And does somebody leverage castings and forgings or additive manufacturing? It's whatever makes the most sense at that point in time, either financially, taking into consideration timeline and what capability we have. So I think that is my end goal. And what does that look like? Is that additive is just another manufacturing method that we use, and it's nothing special to people who are actually using it. I think if that's my vision goal of performance-based qualification, that would be it.
Yeah, Lauren knows.
Mark's smiling. Mark Shaw's smiling, so I'm nervous.
Yeah, no, one of my favorite sayings is metal is metal. So that's what you just said.
Metal is metal. I don't know who taught me that. I don't know.
Yeah, right. The day it's not different is the day we're successful. Right now, because we're handling it with kid gloves, it's really inhibited, and maybe for all the appropriate reasons, but we need to get to a place where it doesn't feel special anymore. So my vision is, maybe a little even more short term, is that I think of what we can achieve within the next couple of years is a qualification standard that's approved and accepted across regulatory agencies. So again, I'm a supplier. I have Inconel 625 in one of my machines, and it doesn't matter what machine it is, pick your favorite machine manufacturer. But on my website, I can say that I am AMS 7032 OQ qualified to Inconel 625. So now when the Defense Logistics Agency is trying to buy that, what would have been traditionally a cast Inconel 625 part, they can look and see, oh, here's a list of suppliers that have met a minimal standard. Is the part qualified? No, but I can go in now from a qualified supplier and have confidence that they've met some sort of universal standard that has a level of acceptability. I mean, that's my short-term goal. And so when I say, within 3 years, that's really the goal, to be able to have an industry that's available and an accepted standard.
Thanks, Mark. That's a good use case. So at a high level, I'll go back to my American football analogy, talking about the end zone. Where are we on the football field? What's the timeline for adoption in your mind? What yard line are we on?
Yeah, you're asking an old football player. Of course, I was on defense, so I was always trying to stop progress. So I'll try to change that. We want a safety. No. I think I want to just say we're on the 50. That may be a cop out. So I say that because there are those, like I started in my intro, that there are those within private industry, some of the large OEMs that have been very successful and have implemented additive even in some critical part applications that have shown them to be safe and being able to control the process. And then I went on to say that a large part of the small, medium-sized business, the metal additive U.S. industrial base, I don't think is where I was in a private industry basis. So I still have a long way to go. And maybe in a sense, I have the same distance to go to get the 50-yard line as I do to the ends of what we did with private industry, we need to do with public. Now, maybe we're probably a little bit along the way. So I don't know, maybe I'm 10 more yards on the 40 or something, but I think that's where we are. But I feel like the ball's moving, and we'll talk a little bit more about that, I think, as time goes on. But I think I'm seeing movement in the industry that I've not seen before.
Well, I was an offensive player, so I'm feeling good about being on the 50. So
yeah, you can kick from there.
Anything you'd add?
Yeah, I played real football, which is soccer. So we're just going to take it out and you can go back to the greatest game. No, I think where we are on the field maybe is less important, and it's what have we learned to help us get to the end zone, right? Maybe we've called some bad plays in the past and we've learned that those aren't working. So that gives us knowledge to call some better plays that can expedite our process to get to the end zone. So in my mind, maybe the question is, what do we need to do to get to the end zone to really accelerate this and to really get moving? And we've done a stakeholder analysis. There's a lot of information out there. And I think it's really on, and I hate to say this, and I don't know how many people are listening, but I bet you 50% of them are going to roll their eyes when I say this, but change management. We need people to be willing to sit down at the table and be open to conversations. For us to truly meet this goal of 10x in 3 years, we're going to have to, the capabilities out there, like Mark said, there's OEMs who have done this, and I completely understand that they have a financial interest into not divulging or democratizing that capability. And I respect that. It's our American economy. So but I still think we need to sit at the table and figure out how can we make this financially mutually beneficial for all stakeholders and players. Raising sea lifts all tides, raises all boats, however that goes. We can get there, and I think we will get there, but we need to have people come to the table and to have those discussions for us to really, really figure out how we're going to move forward. I think we're starting to get there. I think we've learned over the past couple of years who's willing to have those discussions and who's not, who wants to play ball, if we're going to keep going with the sports analogy, and who just wants to sit on the bench. But if we could bring everybody to the table and start to have some of the conversations of, let's move away from the technology and let's start focusing on what does this look like from a business case, and how can we make sure that this is beneficial for everybody, which I believe it really can be. But those are going to be some tough discussions and negotiations, but we really need to start having them to get to that end zone.
Yeah, thank you for that perspective. I think we talked a little bit about this before, Mark, but and we're not going to talk about specific stakeholders, but in general, with your road tour, what kind of response are you getting from stakeholders thus far?
Yeah, thanks. Actually, I want to take a little bit of time and talk about this. I mean, I will tell you, when I left industry and I came, things happen. I'll just say things happen very differently within a closed ecosystem like industry. If I needed to go create just a spec, since we're talking standards here and specs, I would just assign a team and we'd execute on that plan. There'd be a timeline and a delivery. That's just not the way it happens in a world where we're trying to get ideas across multiple industry sectors, OEMs, regulators. But I created my own timeline because I've worked at OEMs for so long. That's the way and I just said, we just need to get this done. Here's what we need to get done. And I started talking to people, and I began, honestly, started taking some notes, and then literally just started redlining some of the standards and said, look, from what I'm hearing, this is where we need to move. And then when I went back to these regulators, when I let's say I was talking to the Air Force, and then I go talk to NASA, I was pretty sure I was going to get pushback and like, well, that's not the way we do it for space. So I'm telling you this long story to say that's actually not what happened. The response has been unbelievably positive. In fact, there's been parts of the Department of Defense, I'm like, I want to just stick with the flying DoD. Like, I want to stay away from like the sea and the land, because it's just going to be different. They're coming to me and said, we want in. Like, I think the recognition that this is such a barrier within the defense industrial base, people are asking to be part of it. And then to the credit of SAE, like, I realized that this is not how it works. Mark Shaw is coming in with, like, I talked to a bunch of people. I think these are, where we need to go. I was just in a committee meeting talking about one of the specifications, and we were nitty gritty talking about, words and numbers and really and like how it all worked. And I will say it was nothing but receptive. That team said, Mark, we see what you did, thanks. And it'll be appropriately challenged, and we're going to debate things. But I honestly felt like people were going to just say, hey, Mark, this is not the way the world works. And that is not the response I had. It has been overwhelmingly positive and enthusiastic. Suppliers, when I walk in the door, they're like shaking like, thank you. Like, you have no idea how much money we are spending qualifying machine after machine. We need a common standard. So this is really one of the good news stories. And it was shocking to me. Maybe I'm too much of an old curmudgeon that's worked in industry too long and expected, to get punched in the face or something. And that's just not what happened. People have been enthusiastic about
That's great.
it.
That's great. So that's the positive side. What are some of the challenges creating headwind?
You go, Mark, based on your opinions. So you went up, let's go down.
I'm going to bring you down. So I'm going to name, let's just name the obvious ones. You know, if you've ever been to an additive manufacturing conference and there's been a panel, we have defined the problem really, really well. So let me just review for the class. We don't have all the standards we need. Even though I'm a believer in one standard for qualification, I need material standard for all the materials. Right? I can't, if I just have Inconel 625, what happens if I need steel? What happens if I need aluminum, titanium? I know, of course, there's some of those out there, but there's not enough. So we need what we call material allowable, design values, and data just to create that baseline so I can perform OQs. I'll speak on behalf of my Department of Defense friends, data rights. Now, I come from an OEM. I understand how money is made on the OEM side, and I understand why there's IP and data rights asserted. But I also know that parts, we have a part problem, a spare part problem. So somehow we need to come to an agreement. I tend to think it's probably rethinking our business model between government. But however that occurs, we need access to data so that when there's an airplane on the ground, we can replace that part as quickly as possible, either through the OEM or through the government. Let's just say it. There's been resistance from the regulator community, right? And rightly so. Since I was one of the first people who went to the FAA, you can imagine what that response was. Like, this was back in 2011. Like, hey, I think I'm gonna 3D print a metal part and put it on a jet engine. How do you think that conversation went? Not too well. Yeah, I normally have more flowery explanation on what the response was. But it really was just sitting down and talking to them and working through what the concerns are. We're still in those conversations is the point, right? And we have multiple regulators. I mentioned them. We have Air Force, we have Army, Navy, we have FAA, we have the European Agency, NASA. They all have different concerns, and we're not to a place yet where it's metal is metal. There's additive. I was asked once, is it the additive part or is it the metal part? I'm like, yes, it's both. So I think those are some of the headwinds that I'll hit one more, maybe this. So economics. The economics are hard. We're buying machines, we're filling factories, we're spending $50 million on machines and factories, and then when I make my first part, guess where all that cost goes? It goes down into the part through depreciation and other means. So the cost basis, the ROI is really, really difficult. Converting technical data is very costly. I've got nearly 100-year-old B-52. What do we have, 75 or something? Whatever number of years it's been flying. How do we convert that to an additive part? Well, it's not cheap because we have to do all the appropriate safety analysis and on and on. So those are the challenges we know. Maybe we can come back and talk about what we're doing, but I'll just hold my tongue here and let Lauren chime in.
Yeah, I mean, my comment was going to be the economics right now. And it's a little bit of a catch-22, right? Because once we democratize this and it's metal is metal, or maybe additive metal is metal, maybe not fully there, but the industry is printing this. This is something that we leverage quite a bit. The cost will go down. So then people will be more willing to use it because the cost will be comparable. But we're not there yet. So how do you encourage people to use additive when it's more expensive so that in the future it will be less costly? So that's a catch-22. I think a lot of us are in. But you have to invest in that to get to that point. And Mark, you brought up the discussion about TDPs, and I saw a comment in the chat. Actually, I don't know if you read it or if you guys are just on the same wavelength. But they were asking about TDP transformation and how do you transfer the legacy old TDPs into being able to be an AM TDP that can be used for additive manufacturing. And in my mind, when I was in college getting ready to join the Air Force, all my friends who want to be pilot, they were told, don't think about the B-52. That's going to be sunset before you guys are commissioned. Don't even put it on, if you want to be pilot, you're not going to be flying the B-52. One of my best friends is a B-52 pilot, and they're re-engineering the B-52. So there is a legacy of aircraft out there that needs sustainment, and we don't have the castings and forging capability within the United States to do that. So in my mind, the business case for that transition from those original TDPs to AM TDPs, maybe that business case is there and that can lead the future. And I'm going down a different rabbit hole, so I'm sorry. But I think we need to invest in this technology now where it makes sense so that we can decrease the cost in the future for wide dissemination and democratization. But it's a catch-22. So
Yeah.
sorry,
That's
I
great
went down a
perspective.
rabbit hole there, but I
No,
got
it's
excited
great.
about the AMTP comment.
No, it's a good one. Can I add maybe some color to, like, I hate leaving it with here's the problem set. In fact, I'm kind of frustrated with that's the way a lot of our conferences end. And like, okay, now let's talk about solutions. So I don't have all the solutions, but there are some of those things we mentioned. There is good work being done, and we are moving the ball, right? Maybe we're now on 35 as we talk. So the TDP, I will pick up the TDP question. So Lauren and I worked together several years ago with helping one of the DoD agencies reverse engineer parts and get them through the airworthiness board. And even today, the way that is happening is sort of part by part, TDP by TDP. And it's possible, and it's demonstrated there's some good pathfinders out there, but it's very, very expensive and it's very, very slow. So my old system engineering brain, when I worked for an OEM, is like, how did we develop an entire aircraft in 5 years and get it through certification? I said, well, we did it as a system. We did it together. So if we did this one at a time, yeah, we will be here for the next 100 years converting the B-52. And maybe by then it will be no longer flying. But if we're very serious about it, we could do it at a system level qualification. We could say, here's a list of TDPs. Here are the probable parts that we want to be at least have the technical data available in the case of urgency. Let's do it together. And maybe there's a flight test at the end. Maybe there's a way that we can not have to do it, but maybe we can do 100 parts at a time, kind of thing, and look at efficiencies. So just because that's the way the world is today, that doesn't mean that there isn't a path forward for efficiency. I do know there's a lot of good work. I'm switching topics to allowables and material data. I have seen an increased level of urgency, funding, and activity in the case of material allowables. I'll just mention America Makes has this program called the Proliferation of Allowables, which NIAR is very much involved with. And there are many alloys that are going to be introduced to MMPDS and become SAE specs as a product of that. Is it enough? No, but the ball is moving. I could keep going, but I just don't want people to think that there's not a problem. The problem's not being solved. It is, and there's a lot of people working on it.
That's great, and it's probably a good segue to some additional positive comments. You mentioned America Makes. They have some interesting work coming in the near future on forgings and castings, so we'll look forward to that. We know that there's the JAMWAG, the Joint Additive Manufacturing Working Group, who are doing great things in the space. And so I want to get to some of the questions from the audience. There was a question early on, how does IQ, OQ, and PQ differ from technology readiness level, manufacturing readiness level?
Yeah, I saw that question. So I'm trying to formulate in my mind something that makes sense. So they're related. They're definitely related. And I think that's the reason the question was asked, because as I explained, IQ, OQ, PQ, it sounds like a progressive maturity of either manufacturing M or technology T and MRL and TRL. But I've not really seen any formal linkage between the two. I have in my own mind at times thought about, gee, if I've achieved OQ, but I'm not into part production, like maybe that puts me at an MRL 6. I'm just making this up. These are not, you won't find this if you're Googling on the internet. What Mark said, OQ is MRL 6. Like there is a relationship is what I'm saying. I don't know if it's MRL 5, 6, or 7. It's somewhere in there. But I would, if I were constructing it, I would put the IQ, OQ, PQ progression. And then I'd probably include things like first article and maybe lot release as well, which doesn't end in Q, but as part of that process, as part of an MRL progression. So they're related. I just haven't seen the direct correlation yet. Maybe a good idea for a standard. I don't know.
Lauren, you do have some Air Force fans in the audience. I just thought I'd make sure to say that. Here's a question. And it's a great one. It's stuff we've touched on, but how do you know when you have a good part? When you 3D print a good part, especially parts that are going to fly through the air.
All right, I'm going to be
I mean, you
cynical. Oh.
Go ahead, Mark.
Sorry, Lauren. So my cynical answer is metal is metal. We know how to inspect metal. It's not different, but obviously there are some differences. But that I do think that I often do, at least in my own mind, but often out loud, answer it in that way. If this were a casting, what would you do? That's what we do. So it's going to be, let me just go through. So I'm going to care about things like dimensional. So I'm going to do the same sort of dimensional inspection. With additive, there's an additional challenge. If I'm combining a bunch of parts together, I have a heat exchanger. There may be areas that I can't touch with a CMM or a micrometer or a vernier. So I might have to use some more advanced modern methods of inspection. I've seen even people using CT scan. It's a little expensive to do, but if you have to measure an internal, or you'd rely on cut-ups or some other things. So you do it in the same way, but there are some complications. Material is the same way. I really care about the same things. I care about, in my world, it was fatigue and fracture. I care about tensile strength. I care about, I could care about surface finish in some cases, if it's a flow, if I'm flowing fluid or air over a device, then I care about those kind of things. And I cared about them before when there were castings and forging. Now we know with additive, at least laser powder bed fusion, it's a rougher surface. So there may be some additional considerations with regard to qualifying those standards. So it's the same, but there's nuances. Go ahead, Lauren.
So I thought about it a little bit differently, shocker. I think the first question I always ask is, well, do you need it and can you not get it? If it's a part that you need and you can't get it through traditional means, either within a certain time frame or the supplier no longer exists, or financially it would just bankrupt you, then yeah, look at additive. I'm not an engineer, but Mark and all of the additive engineers that I have met are extremely smart people. And if you need to have additive work, they will find a way to figure out, like the CT scanning that came out of because the traditional inspection methods didn't work and you needed this part. So you found CT, right? Like human ingenuity is an amazing thing. So if you need the part and you can't get the part, I think the technology will figure itself out. So it's a different viewpoint, but I really think if you need the part, especially if it's traditionally casting or forges, we'll figure out the way to get it made, especially just with the boom of technology within additive. That's such a large umbrella. Yeah, there's so many different ways that you can additively print or manufacture a part. So if you need the part, you can't get it through traditional means, sure, let's figure it out.
Yeah.
Oversimplification.
Good point.
Probably.
Yeah, the only thing I will add is with regard to standards, I do think standards play a role here. So we talked about the role of standards in OQ, but even in PQ, as I get into part qual, I may not specifically be able to give you a part number specific standard, but I can give guidance and I can give direction, just as I outlined. These are the things you typically care about, and here are the means by which you might want to check those or inspect those. So I do think having standards and guidance in this area would be very helpful.
Nicely said, Mark. Thank you. Thank you, Lauren. Really appreciate you having you on as our guest today. I think you've shed some very insightful light onto the national priority for this. It is a technology that is converging in a number of ways. I think you've demonstrated that it's important to the defense and industrial supply base, the supply chain resiliency to maintain aircraft and vehicles. So thank you very much. I want to thank the audience for their participation. It's always nice to have people come and listen to us natter on about what we think is important, and we think this is a priority. Thanks to Tracy and Charlie in the background who made this possible at SAE. And I think wish everybody a great rest of your day.
Thank you.
Thank you.
Bye.